everyone, I'm Kelly Gallagher and we're here at IMTS 2024. We're excited to show you how we are manufacturing the next generation of components, including this transfer case that is installed here on the E-Rod displayed at our booth. In our last stage, we learned how to plan, simulate, and validate using Easy Plan, Line Designer, and Process Simulate to digitally define and validate product assembly to ensure accurate production.
Hi, I'm Josh Carlson, a technical product manager for planning and simulation at Siemens. We're here at IMTS discussing a story around a newly designed gearbox for the Siemens E-Rod. Once we've gone through the entire part planning, production, and design phase, and optimizing that product, we need to figure out how we're actually going to manufacture it. That's where my station comes in. At this station, we talk and demonstrate the assembly planning, simulation, and validation of the newly designed gearbox and how it's going to fit into the vehicle. We start by using Teamcenter Easy Plan to define the manufacturing bill of material and the bill of process required for product assembly. From there, we use NX Line Designer to plan and lay out our station for the assembly process. Next, from the process plan data that we authored in Teamcenter Easy Plan and laid out in NX Line Designer, we load that layout and the simulation study into Technomatics Process Simulate. And from there, we're able to identify potential issues and validate an entire assembly sequence, as well as do some dynamic and static testing for our assemblers. We're also able to validate things such as equipment placement, motions, sequences, ergonomic analysis, as well as tool selection during this phase. What we show here in our demo is a average assembler, male assembler that could be working at a facility, able to reach all of the different parts associated and able to assemble the gearbox successfully, as well as showing some dynamic ergonomic highlighting on the human figure. Then we try looking at a smaller female assembler to understand between workforces whether we can successfully reach the different parts as a quick static test on our ergonomics and our station design. What we find out is the female assembler is not able to reach, so we have a failed reach test. So we can redesign, push it back to NX Line Designer with our design team, update our station design, and see if we can successfully reach all of the different parts. After we update that station layout, we're able to simulate the entire assembly process with our smaller female assembler to make sure that there's not any other ergonomic issues. Once we do that, we're able to optimize the assembly process to make it as efficient as possible and safe for all assemblers at the plant. After we validate and confirm that the operation is efficient and safe for all operators, we're able to move on to actually producing the part and scheduling it for production.